4.1, we started divisibility last time, and we had looked at a bunch of different properties of divisibility, like the properties of divisibility for numbers, and ways of determining if they were divisible by one another. We had all of these different details. We talked about how if we had two numbers that were divisible by the same value and we add them together, it's still divisible. If we have two numbers that are one number that is divisible and one number that's not, and we add them together, they're not divisible. All the same properties held for subtraction. We haven't actually seen us apply this with an example yet. We will in just a moment. And then we went through a bunch of divisibility rules for specific numbers. So we had 2, 5, and 10, where we looked at the ones digit. We had 4 and 8, where we looked at the last two digits as a two-digit number, the last three digits as a three-digit number. 3 and 9 had the ability that if you added the values together and they were divisible by 3 and or 9, the original number would be so as well. And then the last one was this weird rule for 11s where we bounced back and forth between the values and added them together and then subtracted. So if you were gone last time and haven't watched this video yet, you'll want to do that. And then we talked for a bit at the end, about 15 minutes or so, about this divisibility rule for 6. We talked about how it works because when we break 6 down, we have a way to break it down into numbers that don't have any factors in common. 6 breaks down into 2 and 3. 2 and 3 don't have any factors in common, so we can actually test if it's divisible by 6 by testing if it's divisible by 2 and 3. And we are taking a look now at example 2. So we're going to decide if each of the following are true or false, and we're going to kind of try and justify it because even if it doesn't ask us to, we recognize that I like to use the word explain, right? For I can see what you're thinking and not just guessing on problems. So this actually starts with the divisibility rule for 6 as its kind of starting spot. So it says, if a number is divisible by 6, then it is divisible by 2 and 3. So we want to know if that's a true statement or a false statement. If it's divisible by 6, will it be divisible by 2 and 3? So what do you think? True or false? I'm going to make you vote if somebody doesn't talk to me. True? Tessa says true. Does anybody agree with Tessa? Does this sound true? It at least sounds true, right? I mean, this sounds reasonable. And in fact, it's actually divisibility by 6 property. The divisibility by 6 property says the following. So let me go back and take a look with you. It has this statement that says if and only if. Whoops, I didn't get it all circled. Let's try again. Right here, if and only if. So if it is divisible by 6, then it's divisible by 2 and 3. And it means it goes the other direction as well. If it is divisible by 2 and 3, then it's divisible by 6. That's what an if and only if statement does. So when we're looking at this one right here, and we know we have a number divisible by 6, it is true that it will be divisible by 2 and by 3. Another way to do that, if you were just trying to do, like if you were doing a number that wasn't 6, so you didn't specifically have a rule, so you could kind of make a list of like the multiples of 6. So 6, 12, 18, 21, that's not right, 24 is what I meant to say. And it keeps going. Now, while this isn't like proving that it's true, it can at least develop in you a sense of whether or not it makes sense that it would work. Are all those numbers divisible by 2? Yes, because they're all even. And are they all divisible by 3? They're small enough we can probably just look at them and tell. They're all divisible by 3 as well. So yes, this is a true statement, and this would be a way to verify that that makes sense to us. The second one says if a number is divisible by 2 and 3, then it's divisible by 6. So what do you think? True or false?
I'd say you can't do that with like the numbers 2 and 3.
Okay, so why can't you do it with the numbers 2 and 3?
It's not going to give you a whole number. So like if you did 2 divided by 6.
We're not doing 2 divided by 6, right? We want to have numbers that are already divisible by 2 and already divisible by 3. So like, let me give you kind of a description again, because if 2 and 3 weren't the numbers, you might need to know how to go about doing this. If I were to list multiples of 2, it would keep going like that, right? And if I listed multiples of 3, and so forth, then the numbers that this is referring to is anything that's in both lists. So 6 is in both lists. 12 is in both lists. 18, though not written over here, is in both lists. So those numbers that I'm circling are divisible by both 2 and 3. Are they also divisible by 6? Yeah, they are. And so this is also a true statement. And again, because it happens to be the numbers 2, 3, and 6, we could also justify this by going back to this property. This is the if and only if part of this property. If and only if means I can start with the 6 and guarantee that 2 and 3 work, or I can start with 2 and 3 and guarantee that 6 works. It's a bi-directional statement. We can go either direction and it will work. So it's a true statement for both of those. Let's see what happens when we try this with 8, because we don't have a rule that's like this for 8. We have a rule for 8, but it's a little different, right? It has to do with longer numbers, bigger numbers, and this has to work for small numbers too. It says if a number is divisible by 8, then it's divisible by 2 and 4. So we could do the same thing we did, sort of develop the idea from earlier. So we can do 8, 16, 24, 32, 40, and it will keep going. This is a number, these are numbers all divisible by 8, right? Okay, are they all divisible by 2? Yes. Are they all divisible by 4? Yes, they are. This is also a true statement. If 8 divides something, then 2 and 4 are also going to divide it. Okay, now we're going to do this statement, but in reverse, just like we had done for A and B. If it's divisible by 2 and 4, it's divisible by 8. So we can make a list. 2's, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and of course it keeps going. I can do a list of 4's, 4, 8, 12, 16, 20, and it keeps going. And we circled things that are in common to both lists. 4, 8, 12, 16, 20. Are all the numbers circled divisible by 8?
No.
No. What's wrong?
4.
Yeah, we could start even with 4. If you want to feel like maybe you should start bigger just so that it's bigger than 8. You know, it feels a little weird to start smaller than 8. 12 would be the first one. There's numbers that are circled that are not divisible by 8. And again, the reason that happens is because 2 and 4, while they multiply to give me 8, 2 and 4 have a factor in common. It's exactly what we talked about last time failing, right? When they have a factor in common, 2 and 4 can both be divided by 2. I cannot guarantee that 2 times 4 equals 8 will be a divisibility number for the results, right? I can't have that as a property. It won't work. Okay, let's take a look at some others. There's a variety of different things divisibility-wise in this section, so let's look at another one. It says answer each of the following without actually performing the division and explain how you did each case. So the first one wants to know if 34,051, okay, 34,051 is divisible by 17. And it does not want you to actually do division with your calculator or by hand or anything. It's asking you simply to look at this and be able to say yeses or nos. What do you think? Can you tell? I'd like to go back to something we did last time because it actually came up really nicely. And I think it was Madison was the one that noticed it, but I could be wrong. We had this number, 24,015. And when we looked at this, we knew automatically that it was divisible by 3 because somebody said 24 is divisible by 3 and 15 is divisible by 3. Do y'all remember that? Was that you, Madison? Or was that somebody else? It was? Okay, so Tessa remembers it being you as well. I remember it being you. So this is actually exactly what the problem right now we're doing is doing. Because I can take that first part in this particular one and divide it by 3, and I can take the ending part and divide it by 3, it works to be divisible by 3, even without the divisibility by 3 rule. I can apply that same property on, whoops, the next one, this slide. 34. Is 34 divisible by 17? It is. What's 34 divided by 17? It's 2. Yeah. So if you add 17 and 17 together, you get 34. So the 34 divides by 17. How about the 51? These are numbers we're not really very comfortable or common with, but it actually works as well. It's 51 divided by 17 is 3. So this answer is yes. And the reason is because that 17 divides, remember this notation, that vertical bar means divides 34, and 17 divides 51. So since 17 divides each of those pieces, obviously 17 divides 0. I didn't say that, but it's true, right? The 0 is in the middle. It doesn't really contribute in terms of this discussion. But because it divides both of those pieces, it's going to work. What about 19,031 being divisible by 19? It is no. Kira, are you guessing or do you know why?
Because
What are you thinking?
19 times 1 is 19, so that part at the beginning is correct. But 19 times 2 is not going to be.
Yeah, 17 does not divide 31. It's still not 17, it's 19. Sorry, 19 does not divide 31. Yeah, if we multiplied 19 by 2, do you know what 19 times 2 is? It is 38, very good. So it's 38. 38 is not what we have at the end. If 38 was at the end, it would work, but it's 31. 31 is not going to divide evenly by 19, so this is not going to work. How about, again, the goal is not to multiply 2 times 3 times 5 times 7. So if that's what you looked at that and thought you were going to do, you're not. 2 times 3 times 5 times 7 is some number. Is that number divisible by 5? Yes. Allie, you want to give us some thoughts as to what you're thinking on why? Because you're right. Because there's a 5 in it. That's exactly right. The fact that there is a 5 right here is enough. And if you think about it maybe from a fractional standpoint, if you put 2 times 3 times 5 times 7 on the top of a fraction and put a 5 on the bottom, you'd be able to cancel the 5s. You think about it from that perspective. You could also think about what would happen if you did multiply this out. Okay, so without doing so, if I multiply 2 times 3 times 5 times 7, it has to end in 5 or 0. Why? Because I've multiplied by 5. And everything that's multiplied by 5 ends in 5 or 0. Well, if it ends in 5 or 0, then it's going to divide by 5, right? Like that's the rule for divisibility by 5. If it ends in 5 or 0, it's going to be divisible by 5. This one's going to end in 0. And the reason I know is because there's a 2 in the list as well. So the 2 and the 5 in the list actually are going to force it to end in 0. But the easiest way is exactly what Allie said. There's a 5 in it. It's listed there, right? Because, 2 times 3 times 5 times 7 includes a 5. So then, what about 2 times 3 times 5 times 7 plus 1? That's going to be a no. Tessa, talk to me since you're shaking your head pretty strongly on this one.
Because when you add the 1, it makes the end not a 0 or a 5.
Right. Previously, because the same value we just talked about, we knew it ended in 0 or 5, and once I add a 1 to it, that's not going to work. What if instead it had ended in plus 15? Would it work then? Yep, because adding 15 will make the end either be a 5 or a 0, depending on what it started with, it would work. Or you could say that the 5 divided the first part, and 5 divides 15, so it's going to divide their sum, which is the properties we just started with in this lesson. So 2 times 3 times 5 times 7 plus 1 really ends in 1 or 6, right? It's going to end in 1 or 6, so it can't divide by 5. Okay, I'm going to have to clear the screen on the next one because we used it last time for some other stuff. All right, so let's see. All right, this question says, if 24 divides a number, m, what other numbers must divide m? So we encountered this property, though we didn't talk about it quite like that, over here. If I know a number is divisible by 6, then it is guaranteed going to divide by 2 and 3, because 2 and 3 make up 6. If I know a number is divisible by 8, it is guaranteed going to divide by 2 and 4, because 2 and 4 multiply together to give me 8. So with that in mind, if 24 divides a number, what else would have to divide the number?
2 and 3.
Okay, I'm going to start with 2. Let's do it in pairs. What would be the partner for 2 that makes up 24? 12. So if 24 divides it, 2 and 12 will. And then you're exactly right, Kira. 3 works as well, but what's his pair?
8.
8. I'd like for us to go in pairs so we don't miss one. Anything else?
4 and 6.
4 and 6 will work. There is one other number that will divide. It's not a very exciting one. 1. 1 always divides. Its pair really is 1 and 24, right? But 1 would always be in that list as well. So these 7 numbers that are not already included, so 1, 2, 3, 4, 6, 8, and 12 would all divide 24 or all divide M because they all divide 24. Does that make sense? All right. So we're going to decide, they've got these fill in the blank kind of problems in your homework, and they say what number, could go into the blank so that it makes it divisible in a certain way. So we have the number 543,220 something. I can put anything from 0 to 9 in that last spot, but I want to put numbers in that are divisible in these certain ways. So what numbers, like all of them possible, could go in the blank and this number be divisible by 2? 0? 2? Mm-hmm. 8. Thank you, Jordan. Yep. 0, 2, 4, 6, and 8. Where'd those numbers come from, Jordan? Like, why did you choose those?
Because
They're all divisible by 2. That's exactly right. So the last digit's the only one that matters, right? When we're looking at divisibility by 2, we just care about the last digit. And as long as that last digit's divisible by 2, which all of these are, then the original number will as well. Okay? So 2s and 5s and 10s are actually the nicest. 3's not the same thing. I can't just say I'm going to put a 3, 6, or 9 in that blank, right? That's not the rule for 3's. What do I have to do to figure out what this would be for 3's? I need to add all the numbers up. I know I heard somebody saying it. Madison Tessa said it? Okay. Add all the numbers up. So let's add them together. We've got 5 plus 4 plus 3 plus 2 plus 2. What am I at so far? 16? Okay, does 16 divide by 3? No, it does not. So what would I need to add to this so that I would get a number divisible by 3? 2 would work. What's 16 plus 2? 18. Does 18 divide by 3? Yes. Then that 2 would give me a value, right? If I put a 2 right here, I added everything together, I would end up getting 18 as my sum, and that divides. Is 2 the only number? Nope. What else could I put in there? How about 5? Would 5 work?
Yes.
Yes. What's 16 plus 5? 21. Does 21 divide by 3? Yep. So 5 would work. There is another one. 8. What's 16 plus 8? 24. 24 divides by 3. So 8 will work in that last blank as well. Now then, what number could go in the blank so that it's divisible by 6? 2 and 8. What did you do to get 2 and 8?
Compared the answer you got on 3 and the answer you got on 2 and did the compatible numbers.
Yeah. So in order to be divisible by 6, it has to divide by 2 and 3. So we're looking for numbers that are in both lists. 2 is in both lists. and 8 is in both lists. So if I put a 2 in there, it will be divisible by 2 and 3, therefore divisible by 6. If I put an 8 in there, it will be divisible by 2 and 3, therefore divisible by 6. All right, let's look at some stuff about tens. If a number is divisible by 5, can it be divisible by 10? Keyword is can. If it's divisible by 5, can it be divisible by 10? Somebody should say yes. Sometimes, yeah, it can be, right? So yes, it can. Can you give me an example? Because this is asking for basically a justification that it sometimes works. 20. Is 20 divisible by 5? Yes, so it matches the first criteria. Is it also divisible by 10? Sure. So yes. How about the second question? Must it be? No. Can you give me an example? 25 is a great example. Is 25 divisible by 5? Yes. Is it divisible by 10? No. Let's flip it around. If a number is divisible by 10, can it be divisible by 5? Yes. Can you give me an example? 30. 30 is divisible by 10, and 30 is divisible by 5. Must it be? Yeah, this one must work, right? Again, if we were to think about writing out our lists of multiples of 10, 10, 20, 30, 40, and so on, everything in our list is going to end in 0. And the property for divisibility by 5 says if it ends in 0 or 5, and this ends in 0, it'll divide by 5. So it will work. Okay, there's problem solving going on to a high degree in this section. You're going to have to think through the details and merge different details together to find these details or find these answers out. Okay, one last question in this section. Example 4, or 7, rather. All right, it says a number in which each digit except 0 appears exactly 3 times is divisible by 3. For example, 777,555,222 or 414,143,313 are divisible by 3. Okay, so they're telling you that if a digit shows up like 7, it's going to be there 3 times. If a digit over here like 1 shows up, it's going to be in the list 3 times. That's the description. And if this happens, if a number has this property, it will automatically be divisible by 3. First says, explain why this statement is true. Why would that be a true statement?
It's like multiplying that number by 3.
Yeah. So remember our property about multiples of 3 or divisibility by 3 says if I add all the digits together, then it's going to be divisible by 3. Well, I'm adding these in groups of 3. I'll just take the first one as an example, right? If I've added 7 in there 3 times, that's the same thing as having 3 times 7. And then I had 5s next. There's 3 5s, right? So everything has 3 of them in there. So when I add them all together, there's 3 of everything. It's going to divide by 3. So let's write that down in words. Because you have 3 times each number, all added up. The sum is also divisible by 3. Okay, so just because something does work doesn't mean it always has to, or doesn't mean that it has to be the property for it. So this is a statement. It is always true. Must this statement be true in order for a number to be divisible by 3? In other words, must the numbers look like that? Of course not. Can you give me an example of a number that doesn't look like 777,555,222, but it divides by 3? 21, that's fantastic. 21 divides by 3, right? But it doesn't have 3 2s and 3 1s in it, right? So So just because it's a property that's true on A doesn't necessarily mean it has to be that way in order for it to always work. But if it happens to be that way, it is going to work.